Okay, welcome back to ArmanisMath. Today we're going to review topic 3. Topic 3 begins with the idea of graphing polynomials. And at the beginning of topic 3.1, we basically have to know a couple things for this section. You need to look at the degree of the polynomial and the leading coefficient. The degree tells you if the ending will agree or not. If the degree is even, that means both ending will agree. They go together in pairs. So either going to go up, both ending, or both ending will go down. What tells me if they're going to go up or down is going to be the leading coefficient. If the leading coefficient is positive, that means both of them are going to end positive, happy. If the leading coefficient is negative, then both will be ending negative. Okay, so that's the first thing. Second one would be, let's say, something that is f of x. I'll give you the other example when the degree is not even. So let's say I have 4x, I'm going to say squared minus 5x cubed plus 2x minus 4. I don't know how this looks, but I'm asked to basically find the end behavior for this one. How does it behave towards the end of it? Well, first thing first, is this in a standard form? Help me guys with the whiteboard or chat or the live stream comments. It's not standard form. Standard form means I have to start from the highest exponent down to the lowest. So I have to rewrite this one in the standard form. That's going to be a negative 5x cubed plus 4x squared plus 2x minus 4. Now I could look at two things. Number one is a degree, right? Let's look at the degree for this thing. Well, the degree for this one equals 3, which is odd. If it's odd degree, if the highest exponent is odd, that means the ending will be at odds with each other. One is going to go up, the other one's going to go down. One thing is going to go down, and the other one's going to go up. So, come on, Armani. Which one of these? Which case of these? These are two cases here. Is it this or that? Well, that's why you look at the leading coefficient. So, let's look at the leading coefficient. Leading coefficient. In this case, my leading coefficient was negative 5. To me, was negative 5. If it's negative, that means you're going to end negative. Okay, focus a little bit here. If it's negative, that means you're going to end negative. Basically, you're saying you're going to end down. So which one of these two cases will end down? Is it case 1 or case 2? Exactly, it's the first one. So you know that you're going to end down like this. Well, if you end down and you don't agree with the other beginning, that means the guy began at the top or positively, but it's going to end negative. So how do you graph this one? I could sketch it. I don't know how to graph this thing unless if I want to use, for example, tool or some other things, but they're just asking you how to sketch it, basically, not to basically they're asking in this section, they're only asking about the end behavior. So I know that when I end negative, and which means because I'm odd degree, I'm at odd with the other side, so I'm gonna start positive. And what's in here might be something like this. Hold on a second, that's too much, because I know there's gonna be 3 touching points, right? So perhaps something like this, 1 and 2 and 3, something like that. This is not exactly the graph, but this is the sketch of it. Okay. Another idea also in 3.1 would be the following. If I have, let's say I have something like that. I have f of x equals x to the 4th plus 2x cubed minus 13x squared minus 14x plus 24. That's way too long. Okay, and we're trying to find some stuff. We're trying to find some answers here. What is the number of terms? Can somebody tell me how many terms do we have here? Number of terms. Yep, I see that. You guys are saying number of terms. You guys are saying 5. That's very true. That is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 items. Okay, and the number one, no, the second thing is, what's the degree for this thing? What's the degree? Somebody's saying, what's the degree for this? Yep, that is very true. The highest exponent I see is 4. Is this in a standard form? The answer is yes, it is. Thank you. Yes, it is. Well, look, you get 4, 3, 2, 1. What about x to the 0, Armani? Well, it's right there. It's hidden next to the 24. Because x to the 0 equals 1, it's actually here, like it's 1 times 24. Okay? So it's here somewhere. All right. What is what is the turning points? Turning points, and where the I have to give you the graph. And this one, they're nice. Actually, they gave us the graph. So I'll try to sketch this thing here as. Okay, and this would be 40. This point is 40. This touching point is 40. And I've got few points here. Negative negative 4, negative 2, and I've got also 1, and I've got 3. Okay, so let's talk about turning points. Turning points would be things. Let me give you more details on that. This is 30. This is by the tens, by the way. This is this grid here is by 10th, 20th. So this means I have to go down a little bit here, all the way down to 30. This is 30, negative 30. This also goes down to negative 30. I'm not using decimals, that's why I'm just erasing a little bit. So anyway, so down here is this point here. So at this point, I am turning. So if you could look, this is a turning point here. And obviously, if you have a graph with the grid, you could look exactly at that point. You have both coordinates for that point. And also another turning point would be here. 0, 40 is another turning point. I'm sorry, the 0, this would be 25, looks like that. 25. It's 25 here. So this 30. If this is 30, it's going to be 25. So anyways, as I said, if you have a graph, a grid, you definitely could look at the turning points. These are the turning points where the function changes direction from positive to negative, negative to positive. Okay, relative maximum and relative minimum. Well, relative maximum would be, this is the maximum here. See that? These both are minimums. It's just that's kind of intuitive when you look at the graph. That's it. The end behavior. How does this look like when the end behavior? So let's talk about number 4, end behavior. Reviewing what we did just a minute ago. So what can somebody tell me? What kind of end behavior? What's the first thing I look for the end behavior? They will agree. Thank you. So I see an even. So power or the degree is 4. That's even. That means they will agree. And what's the leading coefficient? What is the leading coefficient? Let me look at the chat. It's hidden here at the bottom. The leading coefficient is I need more people to answer. The leading coefficient. What do you see next to the highest exponent, next to the highest ranking officer? What do you see? Yep, exactly. I see a 1. Do you see a positive 1 or a negative 1? A positive. If it's positive, that means I'm going to end positive, and since both of them agree, so both of them are going to end positive, and that's exactly what you see. Both of them are going to end positive. End positive, by the way, the word end positive means as x approaches this side here, like if you have more x's this side, more x's, negative infinity, right? The function itself, or f of x, will also approach, in this case, positive infinity. Basically, you're saying if the x goes like this, how about the y's? Where is the y's going? Where the y's are going positive. Okay, that's one side though. How about the other side of the mountain? Nope, the other side of this graph. Well, what if I want to have more x's like that? Well, let's see. If you have more x's like that going towards positive infinity, what do you think the y's are going? Where is the function? Or what's the y going? Down or going up? Where are the y's going? Are the y's going up? The y's are going up. So if you have more, the y's are going to go up again. Okay, that's in a nutshell that section. Obviously, you do have a video on that section. There's more details, but this is gonna, again, the overview of that section. This is your chance to ask questions before I move on to the next item. Okay, ask questions before we move on to the next one. You could use your whiteboard, private chat. You could use your comments on the live stream. There's a lot of things that you could do. Okay. Could you use chat? I'm sorry, I meant chat. Amaka, can you use chat? I'm on a different. Okay, thank you. So the next item, until I hear from Amaka, the next item would be basically adding, subtracting, and multiplying polynomials. How did you find the degree? Oh, the degree is the easiest. It's actually the highest exponent. So if you looked at the whole function here that is given, I am looking for the highest exponent. That's it. Yep. As simple as that. Good job. That's a good question. That's a very good question, actually. Because without knowing that, we can't move forward. You can't move forward without knowing the degree of the function. All right. Now this is going to be... 3, 2. Adding, subtracting, and multiplying. Okay. So let me add and subtract and multiply. Here is one that so we can add and subtract and multiply polynomials. And in this case, let me start with something that is, say, for example, 2x squared minus 6x plus 2, and addition is fine, so I'm going to actually go to subtraction right away. So I have, let's say, 3x squared minus 2x plus 4. Okay, well, if you want to add this or subtract, you gotta have to get rid of these parentheses here. So I'm going to start taking these parentheses down. So it's 2x squared minus 6x plus 2. And then I got to be very careful, because if there's a negative, and that's why I chose a negative example, you just have to distribute it to every single one of them. Every single one of them will get that negative. So we just have to be careful. Minus 3x squared plus 2x, because negative times negative is positive, minus 4. And then I just have to collect like terms, things that look alike. This guy and this guy look alike. And you could use different colors, or you could use this guy here and this guy here look alike. They are like terms. And finally, I have this dude here with this dude here. So I'm gonna just use one color for all of them here. So let's choose the 2x squared minus 3x squared. Well, apparently the 3x squared is gonna win because that's bigger. So I have a negative x squared. And then I have a negative 6x plus 2. Well, that's the negative 4x. And 2 minus 4, well, that's a negative 2. That's basically what do you do with that one. Any questions on adding? Again, adding would be simpler because you don't have to distribute, basically. Any question on this one? Again, you do have an entire video for details on that. Oops, I thought it was the positive. No, so Marvin got kicked out. Okay, so maybe, is he gonna log back? Thank you for letting me know, Elmer. So we did talk about subtraction, and then we're gonna talk about multiplying. Okay, so let's multiply, and in this case, I have a binomial, which means 2 items, times trinomial, which is 3 items. Bi times trinomial. And let's take an example here. Let's say I wanted to multiply let's say I've got x plus 2 times let's say 3x squared minus 5x plus 4. Okay. What do you think? Do you guys remember? What did I suggest for multiplying? What kind of method do we use? Because there's multiple of them. Yeah, I love the bugs. And if you watch that video for adding, subtracting, and multiplying polynomials, do you remember that roller coaster picture? I love that picture. So I will choose a box. I'm not sure about you, but by the way, you can't FOIL here. FOIL will look at you funny. What are you trying to do? I can't do it. FOIL, I'm only limited to 2 items times 2 items. A binomial times another binomial. But this is not binomial. This is trinomial. So now we're going to say, I'm sorry, FOIL. 3x squared minus 5x plus 4. We've got x. Oops, let me do one more down here. Forgot that. Let's do one more down here. I've got x and then plus 2. Do put the sign next to the number. It helps you, okay? Like, for example, negative 5. Make sure that you put negative 5, positive 2. It's okay. Put it positive 2. Trust me, it helps. So x, can somebody help me out here? 3x squared times x. How much is that? I want to see a lot of you, yes, a lot of you type, not just one. Not just, don't wait. Even if your friend put the answer, don't wait. You also put your thoughts. And remember, here you share your thoughts. They don't have to be correct answers. I know that for sure. I know that you know this for sure by now. So I've got 3x. I've got a square times 1 squared, and then times x. That's 3x to the 3rd power. Negative 5x. Don't wait for me. Do not wait for me, okay? You'll also try this problem. And what do you think I'm going to put here? Ava, what do you think I'm going to put here? 4 times x. I see you writing, Carlos. 4x. And somebody, did somebody work ahead? And what would this be? 3x squared times 2. Yep, 6x squared. And that's a negative 10x. And that's a positive 8. Now, because I did a lot of these in the past, so I'm probably my eyes could spot what's matching here, but I'm not going to do it. I'm just going to be extra careful and list all of them here. But once you do a lot of boxes, you actually could simplify within the box. I don't recommend it until you get very comfortable with that. So I'm actually going to list all of them here. So it's going to be 3x cubed. I need a little more room here. Minus 5x squared plus 4x plus 6x squared minus 10x plus 8. Did I get all of them? Did I get all of them? Okay, now I just have to, again, match or collect like terms, combine like terms. I've got the 3's with nothing. There's no matching to that 3. I got the squared and the squared. And I've got the x's by themselves, the squiggly line with the x's by themselves. And then I just have a number. So I've got 3x cubed plus x squared, because 6 minus 5 is 1. 10 minus 4, that's a negative 6x plus 8. Okay, that's in a nutshell what we get. Good job, Daniela. Any question on multiplying? So basically adding and subtracting are the same. With exception subtraction, you have to distribute. And multiplying, you just, I would use the box for that. All right. Obviously, there's more to this. So my invitation for you is, again, to review the videos. They're there for you. I just pointed them out for you. You don't have to go anywhere. They are actually in your homepage, so you don't have to go anywhere with that. That was 3.2. If you have questions, make sure you ask. Yep, I'm going to do that next. So the third item will be actually dividing. Dividing. Before dividing, there's one more quick things to do. Actually, one more thing to do, which is called the. We're gonna do the division. We will, Daniela. Let's actually review 3-3. This one is the special types of polynomial. Okay, so the special polynomial identities. And the first one in here is the difference of squares. So I've got a squared minus b squared. We talked about this one, and again, there's a video for this whole lesson. This is something being squared. Let me actually put that here at the top. Something being squared at the top minus something else being squared. And I call that difference of squares, because difference in math is also subtraction. So I'm basically saying there is a. All right, let me see what's going on with this software. Here we go. Difference of two things. When the software does that, that means it's really not happy. So let's see if I could take myself out of that. All right. I just got stuck on that. So. Okay. It's kind of locked up a little bit, so I might have to. 1 second here for my software. My software is trying to connect. Okay. That's what this noise is all about. Difference of two squares. Okay. And this has a formula, identity for it, which goes like this. You will have the first plus the second, A plus B, and then the first minus the second. And if you actually could, if you want to multiply these out, you will get this difference of square. Trust me, you will. If you don't trust me, that's okay. You just could do it. You'll find that this is the case here. So let's say something like I have now this difference of square could be something simple or could be something bulky chunky. So let's go bulky chunky. I'm gonna go 16x squared minus 81y squared. Okay, well, you have to look. What's being squared here? What is being squared? Can somebody tell me? What's being squared to give you 16? The 4 is. What's being squared to give you the x squared? So basically you're saying you have 4x times 4x. That's what you're saying, right? To give you that amount. How about 81? How about 81 and the y squared? 9 y's times another 9 y's will give you that amount, which is 81 y squared. So as soon as I know that, I'm able to basically know the basics of the basic component of my parentheses. So I know I'm going to end up with two parentheses. And what's being squared again is 4x plus the 9y. And again, what's being squared is 4x minus the 9y's. Okay, this is in a nutshell difference of squares. The other identity is called the square of a sum. Square of a sum. And this one is unique because this one says you have sum, which is addition. You're adding things. So you could say A plus B. The whole thing is being squared. Quantity squared. So it's called square of a sum. You're summing something and then you square it. So let's take an example on this. Well, this will give you the following. This will give you the first item being squared. Plus, you use that same sign, by the way. Same sign that you have here. Plus would be plus. 2 times first times second. 2 times A times B. And then finally, you will say this is plus the second term being squared. Second term is the B squared. Let's take an example on this. What have I said? For example, we need 3x and then plus, I'm going to say just the y by itself. Quantity squared. Well, what's the first term? This is my A here. This is my A and this is my B. Okay, so I'm going to square the first term. Okay, so you're going to say this is 3x squared plus 2 times the first term, which is 3x, times the second term, which is the B, plus the second term being squared. Well, the second term for me, I'm sorry, not the B, the Y. The Y. And the second term that I'm having here is the Y, right? So it's the Y squared. This is the Y here. Y squared. Just basically now have to clean it up a little bit and make it look nice. So this is 9x squared. Don't forget to distribute the 2 to both of them, right? The 2 belongs to the 3 and the x. So the B is the second. Yep, the B is the second term. Yeah, you're right, Jocelyn. Squared. Don't forget that. Plus, I've got 2 times 3. Well, that's 6x times the y. And lastly, I have the y squared. And that's how you do sum of squares. You added something, and then you squared it. I'm sorry, I meant square of sum. So you add 2 things, that's a sum, and then you put the square of it. So square of that sum. Okay, and then, so I'll just give you a couple minutes here, or just a few seconds here to digest this. This was 3, 3. There's actually a little bit more to that. Excuse me. Let's do a little bit more because we got actually 2 more of these identities. The first one now is going to talk about difference of cubes. And that's when we use the SOAP. Difference of cubes is when we use the SOAP. So I have, basically I have a cubed minus b cubed. Okay? Difference of cubes. And if you guys remember, we did a kind of a pictogram, a picture for this. I'll just give myself more room here. So something being cubed minus another thing being cubed, dot, 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 minus another thing being cubed. Dot, 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 dot. Okay, so two things being cubed. So I'm going to say, for example, let's say have a cubed minus b cubed. Well, there is a formula for this identity. This is going to equal to a, and I'm going to use SOAP for this one. SOAP helps me keep track of the signs. So same, I have S stands for same, so I have whatever I start with, that's going to be the same. That's the negative, and then you have the b. So basically a minus b, that's the first parentheses or first factor. The second factor is going to be the a squared. Whatever the first item is, it's going to be squared. And then I'm going to use O for opposite sign. Well, that's going to be the positive sign. And then I'm going to go to first term times second, A times B. And then lastly, I'm going to use also SOAP, always positive, for knowing the last sign, which is always positive. And then I'm going to say the second term being squared. That's how you factor out difference of squares. So difference of squares would look like that. And this one will be here as, let's just take a quick example here. I'm going to say, let's have 8x cubed minus 27y cubed. Well, what's being cubed here is the 2 and then the x. That's what's being cubed. How about this one here? It's the 3 and the y. That's what's being cubed. Okay, so I know the term is actually going to be 2x minus 3y. And then 2x squared plus 2x times the 3y's, and then I have a plus, always positive, the 3y's being squared. I know it's a little bit chunky, but 2x minus 3y in parentheses, and I have 4x squared plus 6xy, and then I have plus 9y squared. That's how I do difference of cubes. Difference of cubes. Okay, do we have sum of cubes? Yep, there is another one that's called sum of cubes. Basically, you have 2 cubes, but you're summing them up. You're adding them. Plus another cube. Sum of cubes. And in this case, I have a squared plus b squared. A squared, a cubed, I'm sorry, plus b cubed. Sum of cubes. Well, this is the same thing. Again, I'm going to put soap. Soap helps you with the cubes, okay? Just like the soap bar, it's cubed, right? In your, most likely, that's what you use. So soap bars are almost cubed, or in that format, I guess. So A, same, it's going to be plus B. And then I'm going to say the first term squared, and then opposite of that. So actually, let me use a different color for that. Soap. That's going to be plus, and then negative, and then it's going to be always positive. Okay, so A, and then AB, and then B squared. Almost like the difference of squares, but just you have to pay attention to the soap here. The only difference, if you guys look, is the first here. See, soap similar, and then opposite. So let's take a quick example here. Let's say I have 125 x cubed plus 64 y cubed. Well, what's being cubed here? Does anybody tell me what's being cubed here to give you 125? The 5 is, and the x. So that's what's being cubed here. What's being cubed here to give you 64? What's being cubed to give us 64? What times itself 3 times give you 64? 4. So 4 times 4 is 16 times 4. What's 16 times 4? Come on, champions. What is 16 times 4? 64. So I've got 4 y's are being cubed here. So basically the first term is going to be 5x plus 4 y's. And then the big chunky one would be, oh, by the way, I just have to remember to use the soap, okay? I'll use soap here. 5x squared minus, I'm using soap, 5x times 4 y's. And then I have all positive, which is 4 y's squared. So let's clean things up a little bit here. 5x plus 4 y's. 25x squared minus 20x minus 20x and y plus 16y cubed squared. And that's it. That's the end of this portion of 3-3-3. Okay. There's a video on that, so make sure that you watch the video. I've actually ran you through different examples and different combinations, so make sure that you watch that. All right, next one is 3-4. By the way, if we're not able to finish, don't forget that I'm going to put this video up for you guys to review. Most likely also we'll get also some points if you do the homework for it as well. So it benefits on both sides here. One thing before I leave 3-4 though, which looks like I'm going to have to do division on the next video, but I'll give you a link to it as well. I'm going to do... this is still 3-3, so actually go back here so we can finish 3-3. So let's scoot back here. 3-3 also presented another idea of the Pascal triangle. It's called binomial distribution, okay? Or binomial expansion, I should say. Binomial expansion. And in Pascal, if you guys remember, which by the way is going to be on the test as well, expansion. Binomial expansion. This would be the Pascal triangle, and expansion. I'm sorry, there's just one S here. Expansion. there will be something like, let's say, x plus 4 to the 5th power. I am not going to multiply this dude by itself 5 times. I'm not sure about you, but that's not me. So that's why this brilliant guy came up with this example of helping us coming up with something helpful to multiply this by itself, because this says it's 5 times. You could take this 5 times, and if you could do it, I mean, that's fine. But what if I have 10 exponent? Well, so he came up with this interesting thought. He said you could put 1 at the beginning, which is that is something plus something to the 0 power, whatever the exponent here to the 0 power. And then if you want to the 2nd power, you put 1, 1. That's whatever you want to do here to the 1st power. Every row starts with 1 and ends with 1. Pascal. Okay, it's called Pascal Triangle. Every row starts with 1 and ends with 1. So I'm going to start with 1. And then if you start with 1 here, then we're going to have to start now adding stuff up. So 1 plus 1 is 2. Put that exactly in the middle. And then I have also a 1 here. And this happens when you have, let me be on the same line here. So this dude is right here. Something to the 0 power. This dude is something to the 1st power. This dude here is something to the 2nd power. Okay. Stay with me here. So I got this is the 3rd power. Okay. It's going to be 1. What is 1 plus 2? How much is 1 plus 2? That is 3. Exactly. So I'm going to put 3 here. And then another 3, because 2 plus 1 is 3. And then I'm going to end up with 1. This happens when you have the 3rd degree, the 3rd exponent. What if you have the 4th? Well, let's try the 4th. I start with 1, right? I start with 1, and then how much, what do you think I'm going to get here? As I add these up, what do you think I'm going to get here? I'm going to get 4, and 3 plus 3 is 6, and 3 plus 1 is 4 again, and then I end up with 1. Remember, you're going to end up with 1. You start with 1, you end with 1. That's what just Pascal. Now what about the 5th? Well, let's try the 5th. I have 1, and then I've got these 2 guys here, 4. That's 5, right? And then you have to add these, add these, add these. So basically I have 1, and then you got a 5, you've got a 10, you've got a 10, and you've got a 5, and then you will end up with 1. So always like that. So this is to the 5th degree, which is what we're talking about here. They wanted us to do the 5th degree here. So how do I do this? How do I expand this using Pascal? Well, you will use Pascal Triangle to help you come up with the coefficients. So basically, to do this item here, x plus 4 to the 5th power, you will borrow numbers from Pascal. So this is my 5th exponent here. So I'm going to open parentheses like this, bracket I should say. Borrow 1 from Pascal, that's 1. And then take the first item, first term, to the maximum power. X to the maximum power, 5. While the 4 to the lowest power possible, that's 0. So by the way, a safety check for you is the 0 plus 5 is going to give you 5. You cannot exceed 5. If you exceed 5, that means you did something wrong. There's no addition and subtraction within the brackets. It happens after the brackets, between the brackets, not within the brackets. So I borrowed 1, and I'm going to borrow 5 from Pascal. I did borrow 5 from Pascal now. That's 5. Then I'm going to take the first item, x, and then you reduce the power for the x. That becomes 4, while you increase the power for the other guy. So one goes down, the other ones go up. So 4, and then 4 to the 1st power. You close that bracket. Add. 10 from Pascal. I've got x to the 3rd, and then 4 to the 2nd. And then again, another 10 from Pascal. That's 10. And then x to the 2nd, while the other one is increasing to the 3rd, because 3 plus 2 gives me 5. So got the 10s covered. Now we could do 5. 5 times x to the first power and the 4 to the fourth power. 4 plus 1 is going to give you the 5 that you need. And then I need more room. Sure. Plus the last one here, which is 1 from Pascal times x to the 0 power, while the 4 is being raised to the maximum power. That's the 5. Okay? And now all I do, oh, actually I'm running out of time. All I do, if you just want to stick around for a couple minutes, I'm able to finish this one. And by the way, there will be 2 videos for this review, so they will be assigned. So this is a 1 here. So I got basically x to the 5th on this side, plus I've got 4 times, that's 20 x to the 4th. And this dude here, I've got 4 to the 2nd, that's 16 times 10, that's 160 x cubed. And then I have another plus 4 times 4 times, so it's 64. 64 times 10, that's 640 x squared. I know the number is a little bit bulky here. And then let me go like that. 4 to the 4th. How much is 4 to the 4th? 4 to the 4th. Somebody help us out here. 4 to the 4th power. 4 to the 4th, champions. How much is that? 256. So I've got 256 x in here. And how about 60 to 56 times 4? That's 100, 1000, I should say, 24. All right. That's the answer for this guy. I know it's a little bit too much, but that's the answer for this dude. Let's see if we could just scoot it off a little bit here. It's a little bit bulky thing. So maybe I should just put it here so we can have the whole plus 20 x4 plus 60 x cubed plus 640 x squared plus 256 x. Whew, good Lord. Plus the last item that we got, which was the 1024. Okay, that's what we do for Pascal Triangle. If you want to multiply large items like this, expand large items like this. This should conclude our review today. We'll continue with this one in the last two sections. So make sure that you watch both videos to get you ready for the test. Take care of yourself. Be blessed wherever you're at. And